Welcome, everyone. Good morning, good afternoon, good evening, and welcome to episode 40 Space Architecture Design Future Approach to Human Experience. Today's show is dedicated to WTF, What the Future? It's our second episode of Space Architecture and Design, discussing the future approach to human experience and space exploration architecture, Mars, now, and the Moon. I'd like to open this show with an honor, first of all, for these amazing women. I think there are they're very rare, these women by itself, these space architects that are with us today, celebrating also Science Day on the 11th. So this is an honor for the three of you joining us today. And the fitting quote for today's show, quote, "I must commit myself to reforming the environment and not man, being absolutely confident that if you give man the right environment, he will behave favorably." End of quote. Bucky Fuller. So without further ado, let me introduce you briefly to Fanon Bagley, a Vietnamese colleague from California. She's a space architect and co-founder of Nonfiction Design. And Melodie Yashar, also from California. She's a design architect, technologist, researcher, co-founder of Space Exploration Architecture. And our beloved Michal Ziso, also a space architect and CEO and founder of Ziso. Today, we will please hang in the second half of the show. The presenters will present some amazing stuff of their own work. After that, we will join the debate about can designing space help us predict the future of Earth, and how does design for space change our thought process? How does the space architecture and design industry has changed as a result of more women entering it? Turning to you, Michal.
Thank you so much, Ian, and thank you all for being here, the audience here with us on Zoom and on the various social media platforms. I am personally, as I told Melodie right before we started, I'm very, very excited about this one. We've been doing these shows for a while now, and this one specifically is very close to my heart. I'm very happy to have Melodie and Phnam here with us. I find them trailblazers in the space architecture and design in general, and thinking about the future. They're both individually doing amazing, amazing things, and I can't wait to hear them tell us about it more. We will start, we've spoken before, maybe we'll start with Phnam because she has a kind of a macro, I think, presentation, and then we'll dive in deeper into space architecture with Melodie. So this is my pleasure to introduce Fanon Bagley. She is the co-founder of Nonfiction, a creative firm that turns science fiction into reality for a better future. She's trained as an industrial designer and space architect. She creates cutting-edge hardware in wearables, biotech, healthcare, education, transportation, and aerospace. She specializes in turning groundbreaking technologies into attainable, intuitive, and beautiful products that help humans become the best versions of themselves. Phnam works with a variety of companies from Fortune 500s to startups, covering 4 continents. She is the co-host of Future, a video series that demystifies design and the future of everything. So welcome, Phnam, and the floor is yours.
Thank you, Michal, and I'm so happy to be here with all of you. Nice to meet you, Hin. Melodie, wonderful to see you again and to be on the same panel. What an honor. Thank you so much for having me. So space architecture, for those who don't know, this is actually a field that I studied in many years ago at the University of Houston, and came back to very recently, actually came back to space architecture in October 2020. So what I'm going to share with you is kind of like how my path from school to now has been, and how that's going to influence the way I think about space architecture and the way I believe I will influence and hope to influence the entire field. So let me share my screen. So my talk today is going to be about making space more human, right? Which is something that is not really on the mind of a lot of people who work in the space industry, you might think, especially when, you know, we're talking a lot about rovers, about, you know, coming back to the moon and all that. But a lot of the times people talk about rockets, they talk about, you know, the engineering that goes behind it. And obviously all of these things are very important, but making space more human is going to be primordial to the future of space, especially if it's going to include us. So I'm going to start very from a very long time ago. When I was about I was about 12. I had an American cousin send me 2 books. So back then I was living in France. I was born and raised in France. And he sent me these 2 books, A Brief History of Time from Dr. Hawking, and Calvin and Hobbes, which is an American cartoon about a little boy who has an imaginary friend with whom he's, you know, being very naughty and getting into trouble. And so that's when I discovered that I wanted to become an astrophysicist and an artist at the same time. So it's very unusual, I guess, you know, in the 80s to think that you can have this like very love for profound, you know, math and physics and also the arts at the same time. But I knew very early on I was that person. And so in with my very practical brain, instead of becoming an astrophysicist and an artist, I decided to become an industrial designer and space architect. So in 2005, I moved to Houston from Paris, and then went through the SIXA program at the University of Houston and graduated in 2006. And as you can see here, this is all the graduates from SIXA in 2006. SIXA is the Sasakawa International Center for Space Architecture. It is the only graduate program in space architecture in the world, and I believe it still is. And so, yeah, it's a very small program. And this is the type of things that were working back then. As you can see, fairly classic space architecture, you know, pressurized rovers and hoppers and kind of like, you know, systems that help dock parts together. But then a few years ago, you know, after practicing industrial design for about 15 years, I decided to think about what my life purpose was. And so, you know, after going through a whole exercise, I realized that it was turning science fiction into reality for a better future. Right, so you have the element of thinking about the future as this beautiful things that we can build for ourselves. So I started this company called Nonfiction 5 years ago. We're based in San Francisco, and that is exactly what we do. We do more than design. We do more than architecture. We really try to build the world to be this beautiful place. And one way we do it is that we attract clients that have a commitment to at least one of the 17 Sustainable Development Goals put together by the United Nations. So some of them have to do with, you know, health and well-being. Some of them have to do with gender equality. Some of them have to do with the environment or clean water. Another thing that happened recently is that Nonfiction became a member of MIT Solve, which is the social impact branch, kind of like accelerator program where we help, you know, solve a team or, you know, startups help find solutions that can have a positive impact on the entire planet. And so the work I've done over the last, you know, 15 years include a lot of, you know, wearables and hardware design, and really focused on industrial design, development, and mass manufacturing. So this is a brain stimulator that we designed for, you know, athletes and anybody who likes to move their body. Using electricity, it helps you learn movement faster. So using, you know, really cutting edge technology, working with super awesome neuroscientists to get to products that really, you know, shave off, you know, 0.1 seconds out of a record so you can get to the gold medal. Also work with, in neurotechnology, we work with sleep technology as well. So designing wearables that help you get good quality deep sleep. And as we talk about space, you know, all of these products and wearables can be in support of their well-being. So all of these products are part of a subcategory called transformational technology. And TransTech, as it is called, is technology in support of health, wellness, performance, and longevity of humans. We also design medical products. This is the first FDA approved wearable for people who suffer from essential tremors. So you don't have control over your hands and you're tremoring all day long. You can actually wear this product and use electricity as medicine to help you control your hands again. We're also specialists in human ergonomics, designing cutting edge products like these human headphones. They are the first on-ear headphones without a band. As you can imagine, designing something that attaches to the ear so well that you can do a handstand with them and they wouldn't move, it was quite complex because ears are different. You know, there are fat ears and thin ears and small ears and weird ears. Sometimes your ears are different on both sides of the head. So really designing something that is customized to each individual is also very important in the work that we do. Using technology to save lives. We're working with firefighters locally to design, you know, AR rigs using thermal imaging. And that actually helps firefighters see through smokes. You know, using AR technology, you can see the edges of everything. If a ceiling is falling, if someone is moving in front of you, you can shave off quite a few seconds out of a burning building. That can save the lives of people inside, and that can save the lives of firefighters. We're also redesigning the educational system of the country of Singapore, completely redefining what it means to be in an environment that is designed to develop your autonomy, your creativity, your critical thinking, and all of the tools that are going to make the future of work a lot more pleasant for everyone. And one thing that was part of this program is really integrating sustainable practices and really exposing the children to really amazingly beautiful sustainable materials and fabrication models that they can have access to, so they can fabricate the world that works for them. And related to materials, Nonfiction is now an official partner of Material Connection. And so we host one of the largest sustainable material libraries on the West Coast of the United States. We also work in the interior of, you know, airlines, completely redefining what it feels like to be in first class, business class, or coach, and integrating, you know, technologies, vibroacoustics, sound technology, scent technology, integrating nature into the environment, so it becomes more like a spa environment than, you know, just a transportation device. And really reinstated pleasure in flight is very important, and integrated technology that not only supports the people who take the flights, you know, to go on a vacation, on a business trip, but also for the people who work there. Integrating back a bar back in flights could be really cool, and why not think about what that could be in space as well. So now back to space. And the history of you know, space travel, the humans in space, it all started with, you know, surviving space. How do you send a man, you know, up to space and bring them back alive? That was, you know, what Yuri Gagarin started doing in the 60s. And now you have people living on the ISS. You know, it's about living and working. And as you can see, the interior of the ISS, as, you know, useful as it is for the people doing the experiments and living up there, it is quite a mess, right? It's not something that seemed that pleasant to be around and to be floating around. And, you know, from the perspective of a designer, I actually find this type of environment to be quite dangerous. And so thriving in space, what is it going to look like, right? It is our job as, you know, space architects and designers to figure out what that is. So let's jump into it. So when you think of the moon, and you look at the landscape of the moon, it's all grayscale, right? It's this landscape of rocks and powder on the on the ground, regolith, and then you have a nice view of the Earth, but everything else is like black, gray, and white. And the idea here that we developed at Nonfiction is that how do we make color the imprint of humanity on the moon, our neighbor, the moon? So really integrating, on the outside architecture, surfaces that are very beautiful, but also integrate these gorgeous colors that really show that, we are bringing some life into all of this, and texture, and in the things that we put on our bodies and the furnitures that we put in there. And this is actually an architecture that was built, building it underground in lava tubes. Lava tubes are very useful. They're a natural structure on the moon that is about, has a layer of about 40 meters of basalt that protects you from, surface radiation, but it also helps with, temperature control, because temperature down there is a lot more stable than on the surface of the moon. So it can be very useful to build underground. And when you build underground, right, you have control over the entire environment, the lighting, the circadian cycles and all that, by using, a set of LED lights. And when it comes to the interior and the, home pods, how do you think about how it feels to be in this environment? So this entire, structure is not made for the first return to the moon. This is going to be quite a few decades down the line when we send, tens of people to go there and work for long stretches of time. And so when we think of the interior, we think very much of serving the humans who are going to live and thrive in there first. The human body, for example, does not have any straight lines. So why should we live in an environment that has straight lines everywhere? So let's, integrate a lot of these natural shapes, these, curves everywhere, integrating natures and textures, things that you can touch and things that feel good when you look at them. Same thing for the private quarters. When you invite someone in, when you are in your private space, how does it feel to be in there? What kind of colors, what kind of environment, what kind of materials and texture is it going to turn it into an environment that feels like home? And same thing with, working environment or fabrication, using 3D printers and that kind of technology to build all of these structures on the inside. Partially using materials sent from Earth, but also using local materials like regolith and mixing them together to create, structural materials that allows us to print really cool shapes. And in all of this, integrating as much nature as possible, not only to feed ourselves, but also to create an environment that feels a little bit more like home, even if it's a work environment. Same thing for resting or working out environment. Why do we have to use tools that look like they were put together in a garage using tubing and parts that are 3D printed. What we can do is really make the workout environment a pleasant environment, using like moving tools and perhaps some of it can be physical, the impression of running on grass, for example, and some of it can be digital to really expand the way we perceive the interior space of this capsule. And the last project I wanted to go over is actually a project that we did with the WDO and the ISS National Laboratory last October. And it was designed in space for life on Earth. And my team of 14 people actually focused on designing the future of an orbital university. So all of us 14 people were complete strangers, coming from different places on Earth with different backgrounds. Some of us were architects, some of us were designers, some of us were astrophysicists and systems engineers. Oops, what's happening here? Sorry. What happened? Yeah, so we worked together for 2 weeks to design this orbital university. And so this is what it looks like. So thinking about orbits and why you would put a university up there, you kind of have to think about the structure of how a university on Earth is, right? When you think about it, you think of all the disciplines, all the majors that are part of it, and all the research departments, you think of what would be helpful to put up in space. And I think it's up to the people in the future, right? So we were thinking about keeping the same large divisions of a university, which are, STEM, science, technology, engineering, and math. The humanities, having to do with art, and law and all that, and social science having to do with psychology, sociology, and everything that has to do with humans in particular. And so the way this is built is that you have 3 rings that are connected to each other. And what we would want to do is to give access to each of these inflatable pods to, researchers, staff, faculty, and students to have access in space. And really using the microgravity environment to push their research and their development to the next level. And so one way we thought about it is, growing food in space is very big right now. And for example, NASA has like a food challenge out right now. If you guys want to participate, that sounds super fun. So how do you bring back, pleasure and textures and all those beautiful flavors and scents that make food on Earth so pleasurable? How do we bring that to space? How do we make going to the moon or going to Mars, which is going to take a very long time, make food a very pleasurable aspect of it. So the way we thought about it is having, research facility up there that would help, grow a wider variety of food. When you think of hydroponics or aquaponics today, the type of food that they grow is quite limited, right? You can grow lettuce, you can grow capsicum, which are like peppers and things like this. You can grow some fruits and berries, but you can't eat only that kind of food for the rest of your mission. So creating the things like this. And another thing is art, art in space. What can we do there? And there's an artist named Azuma Makoto who has been sending, flowers and bonsais and these beautiful living things up to space. And there's a beauty in this that we can really replicate with student artists in space. What can you do in microgravity? What are the limits of what art is when you practice it in space and when gravity is not working against your imagination? And so, to finish this whole talk, some of you have probably heard of the overview effect, which is talked about a lot by Frank White, a sort of space philosopher that has interviewed countless astronauts. And pretty much all of them have experienced this cognitive shift when they go up to space and look back at Earth and realize that is a very small, very fragile place that we as humans have to protect. And we have to develop all the technology, on Earth and in space to help protect this beautiful place that was given to us. And why are we doing all of this? We're doing all of this for people all over the world, for the next generation, for girls like this girl who lives in India and dreams of space and wants to use space technology when she grows up to help the community she lives in. Right? There's countless people when you talk to people in Nigeria, in Ghana, in India, in South America, everywhere. The kids are very excited about space and they want to be part of it, and they understand that going to space is going to be making life on Earth a lot more beautiful and a lot more human. That's it. Thank you.
Thank you so much, Phnam. Wow, that was so inspiring and interesting, and I could listen to you forever. But We don't have much time for the show, and I really want to get also to the Q&A, so we'll go directly to Melodie now. So let me introduce you to Melodie Yashar. She is a design architect, technologist, and researcher. Melodie develops large-scale, oh, one second, sorry. Melodie develops large-scale additive manufacturing solutions for Earth and space and is working to deploy construction technologies for a permanent human presence on the moon by 2026. Melodie has been a senior research associate in human factors with S.J. Surf at NASA Ames, an instructor at Art Center College of Design, a co-founder of Space Exploration Architecture, Search Plus, a group developing human supporting concepts for space exploration, and a consultant to Icon, a startup pioneering the future of 3D printed housing for Earth and space. Melodie's background is in industrial design, architecture, and human-computer interaction with an emphasis in robotics. So thank you so much, Melodie, for being with us today, and the floor is yours.
Thank you, Michal, for that wonderful introduction that made my job much easier in the beginning of this. I'm very flattered to be here. Thank you for the invitation. I'm very flattered to be sharing this stage with Phnam, who's a designer who I've admired and been aware of within this space for some time, and also Michal, same to you. This is really a pleasure, and I'm super excited and super flattered to have been invited and also to be in this great platform for women. So thank you, Hian, for hosting that platform. I think it's very necessary and it's an important community to be developing, and one that I wish was around much sooner when I got started in all of this work. So I'm going to jump right in. I'll tell you a little bit about how I got started doing the work that I'm doing and take you through the lineage of projects that have sort of brought me to where I am today and what I'm working on today. And I'll go pretty quickly. Let's see. So as Michal mentioned in the introduction, I do work with San Jose State University Research Foundation at NASA Ames, where I work on human systems integration problems. I'm a consultant to Icon via NASA Marshall for some space projects that I'm doing there. And formerly, not formally, I'm a co-founder of Space Exploration Architecture. Many of the projects you'll see here, and also a professor at Art Center College of Design, where we launched the first, hopefully annual Life on the Moon studio, where we were looking almost exclusively at design solutions for how to live in space, and particularly on the surface of the moon. So these are some of the projects I've worked on since 2015 up until the present day. And the one thread, the one consistent theme in all of the space architecture work and space design work that I've done is that in all of these projects, I hope to, and we and our teams hope to synthesize engineering constraints with human factors driven design innovation. So there's a sweet spot in my mind. There's a happy balance between synthesizing those constraints and actually bringing value from a human factors and from a human-centered design perspective. I got my start, and Search Plus Space Exploration got its start by competing in multiple levels of NASA's 3D Printed Habitat Challenge, which is a design competition hosted by Centennial Challenges that was first started in 2015. We continue to participate in the challenge, and ended up winning multiple phases and multiple levels. On the left, you'll see us winning phase 1 for Mars Ice House, and then on the right, winning final design for Mars X House in phase 3, which I was team leader for. So we were the only team to have won multiple levels and essentially all of the final design solicitations for Mars habitats from NASA. This was the trajectory, the history, the trajectory of my involvement in the 3D Printed Habitat Challenge. In phase 1, this was a collaboration between Clouds.io and Search Plus, and in phase 3, this was a collaboration with Search Plus and Apis Core, and we competed in both the design, virtual design levels as well as construction levels. And I'll tell you about some of these projects shortly. So Mars Ice House was the first prize winner in the phase 1 3D printed habitat competition. This was essentially a design proposal for a 3D printed ice shell to be contained within a precision manufactured ETFE inflatable membrane. So you'll see on the inside in this section perspective of the habitat, we have a double ice shell that is surrounding a vertically oriented lander, and then the ETFE is containing all of these elements and the structure, the shell structure itself, so that the ice doesn't sublimate on the surface of Mars. This is a view of the top floor from of that lander, where we were imagining vision windows through the ice so that the astronauts could see to the Martian landscape around them. And a view of the structure at night. We were interested and invested in the idea that the ice shell itself could provide translucency to the outside, so providing natural light, so that the astronauts can maintain their circadian rhythms. And we were also interested in, of course, the potential for the ice itself to act as a superior radiation shield to other traditional materials that are incorporated within space structures. Because water is hydrogen rich, it is a better shield against galactic cosmic rays and solar particle events. When we won that level of the competition, the idea from NASA was that we would the winning team would continue to advance technologies to support the concept for the habitat in later work. But what happened was that the competition was reinstated, not almost certainly because it was too speculative a concept, despite the fact that it had won. But fortunately, we were able to be connected with a principal investigator at NASA Langley who was interested in the idea of an ice home, and together we collaborated on this concept for Mars Ice Home Together, which is not a 3D printed habitat, but in fact a filled and frozen ice shell structure. So here you'll see, again, in a section perspective, that we are imagining multiple material layers, bladder, restraint, and support layers for this inflatable membrane that can contain vertically oriented ice shells. And in this section, you'll see that we've introduced some basic programming for a crew of 4 astronauts to live on the surface of Mars within this ice habitat. But we didn't get too specific about what exactly the concept of operations would be for the mission or for the astronauts themselves. We sort of insinuated that this large adaptable workspace could be suited to whatever activities would be coming their way. And we also insinuated that there could be some greenhouse element incorporated within the habitat, not really thinking to what that might lead to. But eventually, the PI from NASA Langley came back around to us and remembered that we had sort of suggested that a greenhouse could be incorporated within the habitat, and that inspired the NASA Big Ideas Challenge, which was a university competition that I helped co-organize along with Search and NASA Langley to introduce a concept for a sustainable Martian greenhouse that could be connected to the ice home concept and connected to some of the existing infrastructure that would be developed for the ice home. So that's a little bit of the work spinning off from the phase 1 3D printed habitat challenge. These are the 2 projects that we submitted for the phase 3 3D printed habitat challenge, which was the reinstating of the competition by NASA. Mars X House was the first prize winner in the final design level of the phase 3 challenge. This, as compared to the ice house, is actually a regolith, sulfur-based regolith cement that we proposed for the habitat to be 3D printed autonomously on the surface of Mars. The competition specifically asked for regolith-based materials to be considered for the construction of the habitat. And of course, because it's a competition, we very dutifully and respectfully obliged. So here you'll see this is the exterior of Mars X House. It is a vertically oriented structure. You'll notice that there's an exterior egress tunnel that wraps around the structure, and the Hercules single-stage reusable lander to the left of the structure, which we did some very preliminary calculations for the payload that would be required to actually construct this habitat. We were working with APIS Core at the time, and together we came up with this schematic for a robotic printer that could be deployed from the Hercules single stage reusable vehicle. And we came up with an initial concept of operations for how 2 of these printers could actually construct the habitat. Here you'll notice a view of the interior crew quarters within Mars X House. You'll notice that the walls are white because we introduced a high density polyethylene inner layer for all of the interior components, interior walls of the habitat. Regolith is known, well, not known, but Martian regolith is known to contain toxic perchlorates, which could be very hazardous to human health. So we wanted to be sure that we're introducing a material that's actually safe for the astronauts to interface with, hence the high density polyethylene. And this is the top floor of the habitat, where you'll notice there's a recreation area, a kitchen, exercise area. And this is the construction sequence, the concept of operations for how 2 APIS Core printers, even though you'll only see 1 here, would essentially work together to construct the habitat and integrate all of the relevant components of the habitat, such as windows, airlocks, suit hatches, and other hardware and interface components. So the white material you'll notice is the high density polyethylene, followed by the sulfur regolith-based sulfur concrete that is 3D printed on the outside. And then we introduced basalt fiber reinforcement, which you'll see in just a moment. So in this kind of material breakdown, on the far right, you'll notice there's the high density polyethylene, the window assembly for the habitat so that the astronauts can actually look to the outside. We introduced expandable polyethylene foam for thermal expansion and contraction between the materials. Then we have the sulfur-based regolith and continuous basalt fiber for reinforcement. And this is the material system and composite wall of the habitat. This was a 3D model that we actually created for the sake of the competition. This was being exhibited at the London Moving to Mars exhibition, which is a fantastic show that if you guys have not heard about, I would advise that you take a look into. The exhibition catalog is really beautiful. And here is basically the submission that ourselves, Search Plus, and APIS Core conducted for construction level 2 of the 3D printed habitat competition. So the competition itself in phase 3 was split into virtual design, which I just showed you Mars X House was the winner and final design for, and construction levels of the competition to basically show that there some preliminary technology demonstrations that these habitats and structural elements can actually be built. So this was a demonstration that the competition was asking us to do, where we were essentially showing that we can 3D print a water basin, this glorified concrete jacuzzi, and robotically insert a couple of interface elements, these 2 pipes, this large pipe that you see in the picture on the right, and then on the opposite side of the structure, a smaller pipe, and then at the very top, this small portion of a roof. So the idea is that we're trying to show how the 3D printer can interface with other robotic emplacement activities. And then this was us filling the structure. We only filled it 20 centimeters, but that was enough for us to win first place within the competition because almost all of the other structures leaked after they were printed, and there was no caulking and no sealing done before we filled the structure. So that was very exciting. And now to conclude, I recently finished a project with Search Plus as well as ICON and NASA Marshall, which is being affectionately known as the MPACT project, the Moon to Mars Planetary Autonomous Construction Technology effort. This is a multi-team university-based, university, industry, and NASA-based effort to realize construction technologies for the development of a permanent lunar base. ICON is an Austin-based additive construction startup. They are the first, they are known to have produced the first permitted additively constructed house in the US. And and they are leading the way in collaboration with NASA Marshall to actually realize this technology within the next decade. These are the phases planned for the MPACT project. Phase 1 is essentially an initial demonstration on the lunar surface of additive manufacturing technologies. Phase 2 will be an initial demo of a critical infrastructure element, and then phase 3 will be full-scale development of additive and additive construction of lunar infrastructure. And in particular, we're looking at landing pads, roadways, and habitats. Landing pads will be the first thing that we deliver together. And so this is an image of the landing pad design that Search completed with Icon 3D within a schematic design phase, as well as an image of the lunar lantern, which is a habitat design proposal that Search completed with Icon and NASA Marshall very recently. And hopefully I'll be able to share more on this project later. But for now, that is what I have for you today. Thank you so much.
Thank you, Melody. That was fascinating. And wow, so many questions. And our chat here is on fire. There are really a lot of questions. We'll try to get to a few of them. I just wanted to start off by saying, Phnam mentioned in her talk the fact that the ISS is not designed really. And I had a chance to talk to astronaut Garrett Reisman about 2 or 3 weeks ago, and I asked him about that. And he said, you know what, everything is in the place that we need it to be. Everything is very functional. We didn't really notice that it had any impact on us. And I think that is very, very interesting, because usually a lot of us, and astronauts do that too, they are not realizing that their environment and the design can impact the way they use the space and the way they perform. So this is a very interesting shift that is happening now, and it's really, really exciting to see both of your work. And the first question that I wanted to ask both of you, and it was kind of the question that we led with our social media outreach, was WTF, what the future? Do you think that designing for space can help us also predict the future of Earth? I know it's a big question, but maybe Phnam, you want to go first?
Sure. If you think about the future of Earth and all the different, industries that drive it, let's say transportation, right? Virgin Galactic, or the whole Virgin ecosystem is thinking in the long term to make air travel a lot faster, by developing space technology that will influence flying, for example. So yeah, you'll be able to reduce your 10+ hour flight down to 1 hour. And I can't wait for that. And also the future of work, right? The future of education. How is that going to influence it is, yes, we have to develop so many technologies to support life, work, experimentation up on orbits or on celestial bodies at partial gravity. And that is going to have an influence on, how we create environments that are productive and pleasant to be around, how we grow food or eat or, sustain ourselves in a way that is in support of our, psychological, physical, and sociological well-being. So yeah, so many things will happen. And it's kind of like a dance between what's happening on Earth and what's happening in space. One influences the other, and then you have the next generation of kids who have needs and who have a new vocabulary about what's important to them. We have to listen to them, influence industries, and then bring it back.
Thank you. Melody, you want to add on that?
Yeah, I think that design for space, well, when we're looking at, particularly when it comes to habitats and when we're looking at environments for people to survive in space, it really leads us and it forces us to consider the fundamental human needs that we have to sustain in a hostile environment and in an extreme environment such as space. Of course, there's analogs for extreme, remote, and isolated environments here on Earth, right? In harsh environments that would be challenging to design for in any event. But I think that designing for space and in space leads us to consider some of the fundamental elements of what it means to be human and how you design for people and what human needs are. But beyond that, I think that particularly in the Apollo era, it was demonstrated that all of the technology development that sort of led us to those missions and for that enabled that exploration to happen had a trickle down effect and absolutely impacted and influenced the economy of science and technology development on Earth for decades. And I really do believe that design for space will inevitably and should inevitably benefit Earth, and that the two go hand in hand. They're mutually reinforcing. The benefits that we see for when it comes to medical technologies, technologies for human health, air, waste, water remediation, are all developed for space, are all going to benefit Earth in the long run and have applications on Earth today and in the future.
Thank you so much. Yeah, I agree. I think that a lot of people, when they're thinking about designing for space, they're asking, well, what about Earth? And one of the main things that people in the industry, in the space industry, are talking about is how can space, first of all, contribute to Earth? So I think also designing for the future of space, it really is helping us design for the future of Earth. We have many questions. How do you think, Phnam and Melodie, design for space changes our thought process of design? Who wants to take that?
I can start. So a few things. When you design for, because I design for both space and Earth, there are certain challenges that are different in both ways of thinking. Number one is cost, or why you develop things. So the cost or the way you make decisions for product you design for Earth has to do with cost of development and cost of material, right? How many $1 million is it going to take for me to develop this product so I can make hundreds of thousands of them and distribute them all over the planet. And when you design for space, weight has a much more important place, right? Does it fit in a payload, space on a rocket? How heavy is it? Because that has a direct impact on how expensive the cost of sending it up to space is going to be. It's even more expensive if you have to travel to Mars after that. So that's the first consideration. Number two is when we think about humans in space, we have to kill a lot of assumptions that we might have about how humans are going to react, because humans on Earth, for the most part, don't live with the fear of being killed by a random problem pretty much every single day. So thinking about that level of stress, that level, the environment that really supports their well-being is going to be important. For now we're designing for a lot less people, right? There are very few people who go to space, so there's a lot more opportunity for customization and going very deep into solving specific problems. Where when we design on Earth for mass manufacturing, we kind of take an average of what might work for the average person. And so far, the average person is typically 50th percentile male, white person, right? So really customization can go quite far. And kind of like reiterating something we've been talking about before is how does it benefit Earth? Designing for space forces us to think about how that benefits Earth. So there are so many different ways of thinking about how designing for space changes the way we think for designing on Earth.
Yep, I couldn't agree more with what you said. Melodie, you want to add on to that?
Yeah, I think that for me, the real bottom line takeaway and learning that comes that affects almost every area of what it means to design on Earth is the idea of sustainability, and that like Fanon mentioned, like optimizing for mass and optimizing for materials and optimizing for how we introduce new ways of designing in space, inevitably, in my mind, leads to the question of how can we design more sustainably on Earth? What are the resources and materials that we're using? How can we be more responsible about them? How can we think about the environments that we design if we're talking about habitats and if we're talking about habitability? How can the environments that we introduce be more ecologically aware and informed? How can we introduce regenerative systems, closed loop systems that that maximize the potential of the resources that we have and that minimize waste? I think that's a key takeaway of what it means to develop analogous systems for Earth and compared to space.
Yeah. We have a technical question for you, Melodie, about your Mars habitat. What is the proposed method for moving between internal levels?
So in both of the projects I showed, the Mars Ice House and the Mars X House, there's actually an interior stair with an ice house that's inside of the lander, and in X House, it is around the central core. So those are 3D. So we actually introduced 3D printed staircases. So I noticed there was a comment about the exterior egress tunnel. There's actually also circulation pathways inside of the habitat too.
And on the same topic of moving vertically, maybe, Phnam, we had a question also from Chris before, and I'm curious also, how do you take into consideration the gravity if you design for the moon or if you design for the ISS? On Mars, it's also different. So
Yeah, so when you design for floating in microgravity, there's no up, there's no down. You can put things on, what you consider the ceiling, and actually you can take advantage of that fact. And but what is important is to make sure that people who are floating always know where they are and always know where they're going, because there's a safety aspect attached to that, right? And that's why when I look at the ISS right now with like stuff everywhere, on every wall, it sounds a little bit like a headache to me. Whether the astronauts are aware of it or not, they probably feel like they're not aware of it. Like the astronaut we talked to a matter of weeks ago, is because they were trained. They were highly trained to be comfortable in an environment like this. Now, when you think about the future of space, we're not going to be able to train astronauts as much as we do now, dumping millions of dollars and decades plus into their education, their training, and updating all of their knowledge with the technology that's advancing at the same time. We cannot do that. People who are going to go in space in the future are people like you and me, and we have good days, we have bad days, we have days where everything is easy and we can do our jobs. Some other days we need to be alone. So really adapting the architecture, the environment, the interior, the technology that we integrate in all of this to the human sides of humans, right, is going to be primordial. Because right now we treat astronauts like superhumans, which in many ways they are, right? And so we have to do the same with partial gravity. Third of gravity on Earth gravity on Mars, sixth of Earth gravity on the moon, and there are certain things we can help with pressurization, but there are other aspects that we can help, adding some weight into the clothing and the shoes that we carry, working out in ways that actually support the entire body and mental health as well on a daily basis, making sure that the connections between humans physically and psychologically is done in a way that respects the person as much as supports them in every way. Does that make sense?
Yeah, I mean, I think it's almost philosophical question, because as you were saying, that we will not have the time to train astronauts as we do today. And if we have the opportunities of different types of gravity on the ISS and on the moon and on Mars and on other planets, should we try to put effort into, you know, rotating elements that to cancel out, or to create the gravity, so that all those people, the new astronauts, will be more accustomed to the way they are here on Earth? Or should we take advantage of those you know, different conditions, and really, you know, try to see how we can benefit from them? I think that's an interesting, I mean, we can talk about this. I think it's a very, very interesting philosophical even question of, should we try to create another Earth? Should we try to create similar things that we have on Earth, not even going up and down, but all other building blocks? Or should we really think about how to do things new and right and fitting to diverse people and astronauts? And we don't have much time left, but I really want to touch on our last question. We are, as we mentioned at the beginning of the show, we are marking the International Day for Women and Girls in Science. It was on the 11th, 2 days ago. And as you can see here, we have 3 space architects. And how do you think space architecture and the design industry change or can change due to the result of women entering it? Melodie?
Well, I don't know if I can comment on the space architecture discipline specifically, but what I do know is that in arenas and in work environments that have omitted, for better or worse, and whether intentional or not, and that have not been inclusive to people of like to women and to other, I guess you could say, demographics that are more diverse, they are missing a critical perspective that that is better suited towards compromise, that is better suited towards creative and new ideas, and is just really unfortunate. So I think that the more women scientists and engineers that I speak with, the more they agree that working with and collaborating with a a more diverse group of people, both internally at NASA and externally, is always to everyone's benefit. And it's something that is only palpable once you see it and once you recognize it. And I fundamentally believe that women are better collaborators and negotiators and listeners, and yeah, bring a lot to the table.
Thank you. Phnam, you want to add anything else to that?
Yeah, that's wonderful, Melody. I've always believed that women are very good connectors. So when you take 2 fields where humans have developed wonderful innovations over the decades and all that, you see a lot of specialists, people who are really know their stuff and know how to build, you know, everything. But I've realized that women have been very good at taking 2 fields that never talk to each other and connecting them, and creating almost a third field that that answers questions that nobody else has put on the table. And because of that, I believe that is completely primordial to the future of many industries, including the future of space. The future of humans in space, the future of work is the same. The future of even universities, right? You see today people in their 20s going to college and say, hey, I'm interested in this major doesn't exist, I'm just going to create it. I'm going to take, you know, this expertise from this field, this expertise from that field, merge them together and see where that goes. And I cannot wait for more and more kids, you know, young people in the world to start doing that, and to stop thinking that, you know, success is having high IQ, or success is being an engineer, or, you know, good at math and all that. Success is a lot more than that. Success is being able to walk in the world and believing that what you can create for yourself, or you can inspire others to create, is going to be wonderful for everyone.
That's an amazing answer. Thank you so much for now. We have to wrap up, but I see a lot of questions here on the chat, and I'm guessing we have some more even from social media. So I will give the floor for like 1 minute for each of you just to say how people can contact you, or maybe you want to write it on the chat, but also give like your final 60-second, bottom line for space architecture. Phnam, you want to go first?
Sure. So space architecture is in its infancy, right? Humans have been, in space for not even, 50 something years. And we're already thinking about going to Mars and becoming an interplanetary species. This is going to take a lot of work. This is going to take a lot of imagination. This is going to take a lot of risk that all of us are going to take. And we cannot do it the way we've been doing it, for the ISS, for Apollo, for all the previous missions. We have to think of new ways of doing, new ways of fabricating things, new ways of protecting ourselves, new ways of dealing with the harsh environments we're designing for. But most importantly, we have to make it human. There's no way to do it just with math, just with engineering. We have to do it with all the imperfections that makes us perfect.
Amazing, thank you. And please, if you can add on the chat if people want to contact you, how they can do that. And Melodie.
Yeah, I agree that space architecture is still in its infancy, and I want to emphasize that it is not only the discipline relative, it is not only the job of engineers and scientists to get us to space and to realize a future where a diverse crew of everyday astronauts can make it to space, to the moon, and eventually to Mars. I think that the workforce and the task of actually getting us to space and to realizing an interplanetary civilization is going to take not only scientists and engineers, but anthropologists, psychologists, artists, and many, many other disciplines that need to work collaboratively to think of what it means to be a first peoples, to think collaboratively about what it means to establish critical infrastructure and design for the needs of many types of people, and not just, like Phnam mentioned earlier, highly specialized, highly trained fighter pilot white male crews. And I'm really excited for that future, because I think that it is susceptible to influence, and it is new space is an open space. I think that the barriers to entry are much lower than they had been in the past, and it's a very exciting future for us to be thinking about what it means to actually become the first humans to actually inhabit space sustainably and permanently.
Yeah, so exciting just hearing you talk about this, and I'm getting excited all over again. Thank you both so much. Melodie, also if you can write on the in the chat how people can contact you maybe, and I will give the floor to Hien to wrap this up. Thank you again, this was fascinating, and you both are doing such an amazing work, and so important work and inspirational work, so thank you so much.
Thank you so much, Michal, for moderating, Melodie for everything that you do. What an honor to be here. We could talk forever, completely honest. Yeah, thank you so much.
Thank you so much,
everybody. Thank
ladies.
you, Michal.
It was
Thank
an
you,
amazing
Hien, for
panel.
hosting.
I learned so much. Thank you so much for being this amazing role models. Thank you for Phnam showing us how space can make us more human through your design work. I'd like to be your customer. It's amazing. You brought all aspects in, every single SDG, including health. Melodie, for your congratulations for all of your great work and accomplishments. Onwards, ladies. So I invite everyone. Thank you for your participation, and I'll invite everyone next week's show, Closing Gender Gap Through Astronaut Training, with a visionary entrepreneur, Claudia Kessler. She's been on the show before. So I hope we see you next week again, everyone. Thank you, and stay well, everyone.